Newton, the science superstar. Isaac Newton was a brilliant scientist. He lived a long time ago but made discoveries that changed the world. Newton is most famous for his 3 laws of motion. These laws explain how objects move. Newton's laws are important because they are used everywhere in science and engineering. They help us design cars, airplanes, and even send rockets into space. Without Newton, our understanding of the universe would not be the same. Newton's first law of motion is called the law of inertia. This fundamental principle was first formulated by Sir Isaac Newton, one of the greatest scientists of all time. It explains how objects behave when no external forces are acting upon them. Inertia is a big word, but it means that objects like to keep doing what they are already doing. Whether an object is at rest or in motion, it will continue to stay that way unless something causes a change. This is why a toy car will stay still until you push it, and once it's moving, it will keep going until something stops it. If something is still, it wants to stay still. For example, a rock lying on the ground will remain there indefinitely unless an external force like a person or an animal moves it. This is because the rock has inertia, resisting any change to its state of rest. If something is moving, it wants to keep moving in the same direction and speed. Think about a car driving on a straight road or an athlete running on a track. They will continue moving forward unless they apply the brakes or encounter some resistance, like friction or air resistance. Think about a book on a table. The book is at rest, it's not moving. This is because the forces acting on it, like gravity pulling it down and the table pushing it up, are balanced. The book is at rest, it's not moving. It will stay there unless something pushes or pulls it. That's inertia. This principle is why you need to apply a force to move the book from its resting position. It will stay there unless something pushes or pulls it. That's inertia. When you push the book, you are applying an external force that overcomes its inertia, causing it to move. Now imagine a spacecraft in space. Space is a near-perfect vacuum, meaning there are very few particles to exert forces on the spacecraft. Once the spacecraft is moving, it will keep moving at the same speed and in the same direction forever, unless something acts on it, like a booster rocket. This is because, in the vacuum of space, there is no air resistance or friction to slow it down. The only way to change its motion is by applying another force, such as firing a booster rocket to alter its speed or direction. Newton's second law of motion tells us how force, mass, and acceleration are related. This fundamental principle of physics helps us understand how objects move and interact with each other. It's a cornerstone of classical mechanics and is used in various fields, from engineering to everyday life. Force is a push or a pull. It can be seen in many everyday actions, like pushing a door open, pulling a toy wagon, or even pushing a car when it breaks down. These actions all involve applying force to move an object. Mass is how much matter something has. It's a measure of an object's resistance to acceleration when a force is applied. For example, a heavy object like a boulder has more mass than a small object like a pebble. Acceleration is a change in speed or direction. When a car speeds up, a runner sprints faster, or a ball rolls down a hill, they are all accelerating. Acceleration can be positive, speeding up, or negative, slowing down. Newton's second law can be written as a simple equation. Force F equals mass, m, times acceleration, a, or F equals sine ma. This equation shows that the force applied to an object is directly proportional to the mass of the object and the acceleration it experiences. Imagine you're pushing a shopping cart. This common activity can help us understand Newton's second law in a practical way. If the cart is empty, it's easy to push and make it accelerate. The low mass of the empty cart means that a small force can produce a noticeable acceleration. But if the cart is full of groceries, it's much harder to push and make it accelerate. The increased mass of the full cart requires a much larger force to achieve the same acceleration. That's because a full cart has more mass. The greater the mass, the more force is needed to change its motion. This simple example illustrates how force, mass, and acceleration are interconnected in our daily lives. Section 4, Law 3, Action and Reaction, Jumping off things. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This fundamental principle of physics is crucial in understanding how forces interact in our everyday lives. This means that whenever you push or pull on something, it pushes or pulls back on you with the same amount of force. For instance, when you push a heavy object, it resists your push with an equal force, making it challenging to move. Imagine jumping off a small boat onto a dock. This simple action beautifully illustrates Newton's third law in action. When you jump, the action, you push down on the boat. Your legs exert a force on the boat, propelling you upwards and forwards. At the same time, the boat pushes back up on you, the reaction, with an equal force, causing you to move forward and the boat to move backward. This reaction is why the boat moves in the opposite direction when you jump off it. Rockets launching into space use this same law. The engines expel gas downwards, the action, and the rocket is propelled upwards, the reaction. This principle allows rockets to travel into the vast expanse of space, overcoming Earth's gravity. Even swimmers use this law when they push off the wall of a pool. The force they exert on the wall propels them forward through the water, demonstrating action and reaction in a fluid environment. Walking is another everyday example. As you push your foot against the ground pushes back with an equal force, allowing you to move forward. Newton's third law is at play in countless activities we perform daily, often without even realizing it. Section 5. Newton's laws, a quick review. So, there you have it. Newton's 3 laws of motion. 1. Objects in motion tend to stay in motion unless acted upon by a force. 2. Force equals mass times acceleration, F equals sign ma. And 3. For every action there is an equal and opposite reaction. Newton's laws are all around us. Understanding them helps us understand the world we live in, from why things move to how rockets fly. Section 6. Fun fact. Did you know that Isaac Newton also made important discoveries in optics? He discovered that white light is actually a mixture of all the colors of the rainbow.